values from there. Extract omega, extract k, extract lambda, or anything that is required. That kind of questions are coming in the examination, it will come. Then we learnt about superposition principle, where two waves are superimposing to each other, and the net displacement of particle will be the vector addition of both the waves displacement, y1, y2. If you add both y1 plus y2, vector addition, then you get the net displacement of a particle. And that when we did equation wise, we got the equation as, if you remember, we got the equation of y1 y2 as this, 2a cos phi by 2 sine kx minus omega t plus pi by 2. Once again I am repeating, a here is 2a cos pi by 2. From here also question is going to come in the board exam, not board, your examination. So this is not the equation of a wave. Since we have 3-4 equations here, you will have this confusion. What is the equation of progressive wave? What is the equation of reflected wave? What is the equation of superimposed wave? If two waves are superimposing each other, then the equation becomes y is equal to a sine kx minus omega t plus phi by 2, and here the a is 2a cos phi by 2, and that decides whether it will be a constructive interference or destructive interference. I have told to you about the condition when the interference can be constructive, when the interference can be destructive. In constructive interference, amplitude becomes maximum, that is plus or minus 2a. In this case, 2a cos phi by 2 only is the amplitude, right? This has to be maximum. If you do that equation solving, you will get the value of phi as 2n pi. It means if two waves are coming with a phase difference of 0, 2 pi, 4 pi, 6 pi, 8 pi, 102 pi, 3468 pi, all the even pi's, when they collaborate together, it will make a constructive interference. If two waves having a phase difference of 2n pi, n starts from 0, you are going to get a constructive interference. It means you are going to have extreme. It will become double. And when two waves are going to superimpose with a phase difference of remaining pi's, what is remaining? Pi, 3 pi, 5 pi, 7 pi, 9 pi, 11 pi, 3733 pi, and all the odd pi's, you are going to get a destructive interference. So, if a question I ask in MCQ category that the phase difference between two waves is 27 pi, what is the interference? Answer is destructive. If the question is two waves are superimposing with a phase difference of 66 pi, what is the interference? The answer will be constructive interference. Just by seeing the phase difference, you can comment whether it is going to be a constructive interference or destructive interference. Sanjeet, last warning, one time if I see your video off, you are out of the meeting today. Others also, except Sai Rakshana who has got permission, everybody's video should be off. Sukendran. Yes, coming back. So, this is about constructive and destructive interference. Be very clear in this. Next, I talked about boundaries. I said when a wave is going and hitting a boundary, how it is going to behave is totally depending upon whether it is a free boundary or it is a rigid boundary. Free boundary will allow the wave to move, the string along to move with the wave. Rigid boundary will reflect it. In rigid boundary, there will be reflection along with phase change, whereas in free boundary, the reflection will be without phase change. So, if you are having y is equal to a sine kx minus omega t, after hitting a free boundary, it will become y is equal to a sine kx plus omega t. But if it is a rigid boundary, it will become y is equal to a sine kx plus omega t plus pi, because we are going to have 180-degree change of phase. We even solved some questions based upon that, some diagram I gave where you saw how the waves are changing. These kind of questions are also coming in the examination, where they are asking you to find what happens when you have a rigid boundary or what happens when you have a free boundary. So, in the rigid boundary, as I said before some time, there will be a phase change of phi. So, the reflected wave will have the equation a sine kx plus omega t plus pi. Pi is 180 degree obviously. And if you are encountering a light boundary or a free boundary, then what will happen? It is going to allow the wave to move along with it, and it is going to create no phase change, only the wave will get reflected back. So, if it is equal to y is equal to a sine kx minus omega t, y reflected will become y is equal to a sine kx plus omega t. That is all. Same thing I have written here, you check. Y is equal to a sine kx minus omega t, reflected will have a sine kx plus omega t. Then I talked to you in the previous class about even refraction, where you have two strings, that is light string and heavy string together connected. So, suppose you have a connection in which we have a string like this, a light and a heavy, then heavy will behave like a denser medium, this will behave like a rarer medium, when the wave comes, hits the point of intersection between light and heavy, it will reflect back, its amplitude becomes down, and if you see, one wave got refracted, some wave got reflected. You can, if you are understanding the equations of wave, you must realize if this is equal to y is equal to a sin kx minus omega t, reflected wave will become y is equal to a sin kx plus omega t plus pi, and this will become y is equal to a sin kx minus omega t only. But a will become a2 because amplitude has got reduced. You can see the diagram, right? How the amplitude was after the hitting, it's got reduced. So incident wave y is equal to a1 sin kx minus omega t, reflected wave y is equal to a2 sin kx plus omega t plus phi, phi means pi, and y of refracted wave is y is equal to a2 sin kx minus omega t. No change in phase, no change in direction. Whereas opposite happens when you have a string which is heavy encountering a light string. When a wave moves to that point, after it hits that point, what happens? You can see the wave travels in the same direction, no phase change happens. So incident wave has the equation of y is equal to a sin kx minus omega t, amplitude will reduce. So this will become, that is refracted wave will become y is equal to a2 sin kx minus omega t, and reflected wave will become y is equal to a sin kx plus omega t plus no pi, because we have here heavy meeting light. If heavy meeting light, no phase change. If light meeting heavy, 180-degree phase change. I have told about this to you. And then we have learnt about standing wave, very interesting concept. I told you, when two waves are superimposing each other, incident wave, reflected wave, both are progressive waves. One is in this direction, other is in this direction. When they superimpose each other, we get a special type of wave called as stationary wave or standing wave, which gives a feeling to you as if it is not moving. See here, the blue one is incident wave, the red one is reflected wave, and the black one is the stationary wave or standing wave. You can feel that it is not moving itself. Blue moves towards right, red moves towards left, but when they superimpose, this wave seems to be like going up, down, and very careful thing is that here this point is node, it will always be node. If any particle is lying at node point, it will never have any displacement, but here all the points will have displacement. So here every particle will get a chance to become node, it means that mean position, maximum position. But in standing wave, a particle has a fixed position. If it can go plus 2 centimeter, it will always go 0, plus 2, minus 2, plus 2, minus 2. Amplitude may be 10 centimeter also, but amplitude will be felt only by antinode points. If it is antinodal point, then obviously it will have plus 10, minus 10, plus 10, minus 10. And at a particular time, here we will get a second that everything is becoming 0. See, 1 second everything is becoming 0. But here never you will get a time when all the particles at 0 displacement. These things are very conceptual. I cannot feed you inside your head. If you are understanding, you are understanding. And obviously it needs thorough understanding of the last 2 classes. Fine. Then equation of standard wave, when you found y1 and y2 when we superimpose with each other, then we got the equation as y is equal to 2a sin kx cos omega t, where how I have solved, you remember, basic trigonometric function we have taken, and then amplitude is equal to 2a sin kx. Once again, I think last class in SSM Nagar when we solved a question, I gave a question of stationary wave where the amplitude was taken as 2a sin kx. You remember? Those who were there in SSM Nagar, they may remember. We took a question from stationary wave numerical, and there I told you a should be taken as 2a sin kx. These things you should know. See, we have multiple equations here. Equation of progressive wave is different, reflected wave is different, refracted wave is different, stationary wave is different, isn't it? You should be very clear in how the equations form, but the concept is very simple. If you understand that, then nothing is there in this chapter. Okay. Then about nodes and antinodes, I told you nodes are those points which will never have any displacement. See here n, 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 n. All the nodes are always at the 0 position. It will never have any up or any down. Whereas A are called as antinodes, and they fluctuate to the maximum displacement. You will see a maximum amplitude, minimum amplitude. and they will always be under that. But A at a particular point becomes 0 also. Are you feeling that? It is maximum 0, minimum 0, maximum 0, but node always 0. It cannot have any other displacement. Next, we have found the positions of node by equating that a sin 2a sin kx as 0. We have got the nodal positions as 2 pi by k. So all the points which are having distance between them as n lambda by 2, you are going to have nodal points. That is, if you see lambda by 2, then again lambda, then again if you put here n is equal to 1, lambda by 2, n is equal to 2, lambda, n is equal to 3, 3 lambda by 2, you are going to get all the nodal points. Distance between two nodes will be how much? Lambda by 2, because if you subtract two things, it will be always lambda by 2. So always remember, distance between two nodes in a stationary wave is always lambda by 2. Then I talked about antinodes. Antinodes are the point between the nodes, and when we equate and try to find what is the solution of that equation, we got the value of x as n plus 1 or 2n plus 1 by 2 into lambda by 2. So it will become lambda by 4. Check. Distance between 2 is lambda by 2, but the first node will form at lambda by 4. Then again, accordingly, it will keep on moving. But if you take two nodes, two antinodes, they will also have a distance of lambda by 2. It means two nodes or two antinodes, they are always separated by lambda by 2 position. These things, please go to the last class notes if you are having confusion. And yeah, then we even talked in the last class about strings and organ pipes. Yesterday, last class was a very long class. Lot of things we learned. So in the last class I told you how the string behaves. If the string you see, these 2 points are always going to be at nodal points because they are fixed. If I give a displacement here, you will have a displacement here, we will have antinode. So node, antinode, node, and we will find the fundamental frequency, then we will find first harmonic, second harmonic, overtone. You remember all these things we did in the previous class, where for every case we are finding the fundamental frequency, or we are calling it as first harmonic, and then second harmonic, third harmonic, fourth harmonic. In the case of string, we will get all the harmonics, nu 1, nu 2, nu 3, nu 4. What is the fundamental frequency of this string? You remember? V by how much you got? V by 2L. V by 2L is the fundamental frequency of string. Check your notes. We have derived this itself. V by 2L is the fundamental frequency of string. Second harmonic will be how much? 2E by 2L, that is V by L. 3 will be how much? 3 into V by 2L, that is n times of V by 2L will give you the nth harmonics. Or we can say first overtone. Second harmonic is called as first overtone. 10th harmonic will be called as 9th overtone, isn't it? So be very clear in that. Which is the overtone? What is the frequency? What is the harmonic? Be very clear in that. Question will come, they'll ask, find 6th overtone. 6th overtone means what they are asking to find? 7th harmonic. 7th harmonic. 7th harmonic will be how much? 7 times of V by 2L, that's all. Question will be simple. But if you don't understand the logic of overtones and harmonics, you will make mistake. Then I talked to you about organ pipes. There are two kinds of organ pipes. One is called as open organ pipe, another is called as closed organ pipe. In open organ pipe, two ends are open, and we will blow the air from somewhere in the middle. Middle means some part. If it is a closed organ pipe, one end we are closing by our mouth itself, and then we have some holes in the flute or any musical instrument. Those holes are used to control the nodes. So wherever you put your finger in the hole, it will create a nodal point there. So we can control how many harmonics you are going to produce. When we derived both open organ pipe and closed organ pipe, we came to know that in closed organ pipe, we have only odd harmonics produced. That is nu 1, nu 3, nu 5, nu 7, nu 9 and so on. But in the case of open organ pipe, where both ends were opened, we have all the frequencies audible to us. Nu 1, nu 2, nu 3, nu 4, nu 5 and so on. What was the fundamental frequency of open organ pipe? Remember? Fundamental frequency of open organ pipe, how much it was? V by 2L. So you can remember that open organ pipe is very similar to string, exactly to string. String also fundamental frequency V by 2L. Here also V by 2L. There also second harmonic is 2V by 2L, that is V by L. Here also V by L. Third harmonic 3V by 2L. Here also 3V by 2L. Same like how a string's frequencies are varying, the frequencies of open organ pipe also varies. But in the case of closed organ pipe, nu one will be how much? V by 4L. Remember, don't forget this. V by 4L is for closed organ pipe, fundamental frequency. The third harmonic will be how much? 3 into V by 4L. Fifth harmonic will be how much? 5 into V by 4L. We will not be able to hear second harmonic, fourth harmonic, sixth harmonic, anything. We will be able to hear only first, third, fifth, seventh, ninth, 11th and so on. I hope you are understanding this. That is the concept of closed organ pipe. Questions are going to come in any way. They'll ask length of the pipe to you, length will be given, they'll ask some harmonic to you. Until you are very clear with the concepts of organ pipes and strings, you will do mistake in this. And again I am repeating, in all the school examination, when this chapter comes in the syllabus, then you will have a 5-mark question coming from organ pipes or string. And derivation is damn simple. It's very simple, right? That I told you, I gave the trick also to you, how to find how many waves are there. So I gave you like deciding quarter of wave, adding and all these things. Last video, if you can see if you are confused in that. But up to last class, we have finished almost 90% of the chapter. Today, small part is remaining that we are going to finish. The first thing is we are going to talk about the velocity of the waves, and then we are going to talk about the beats. This chapter is done. Then we will start thermodynamics. What remains is thermodynamics and KTG, that I will be taking later. So let us start today's class. I am going to enter into the topic now, and that topic that I am going to enter today, the first topic is about the wave speed on a stretched string. Okay, all of you are clear up to here? All of you are clear up to here? So again I am repeating this chapter, please for God's sake, see all the videos if you have not seen yet. If you are not clear yet, make yourself clear. Even if you have problem after that, come to me, I will teach you once again. But don't give up this chapter. It's a simple chapter, scoring chapter, interesting chapter. So please go through all the content that I have put in the group, or if you have taken the notes and you understood it very well. But please make sure that you are not missing out something in this chapter. Coming back. So now we are going to talk about speed of the waves. So I have said you, in this chapter we are going to talk about two kinds of waves, transverse wave and longitudinal wave. Transverse waves are those waves where the particles of the medium are oscillating perpendicular to direction of propagation. Longitudinal waves are those waves where the particles of the medium are vibrating parallel to the direction of propagation. In the case of longitudinal waves, you are going to have compressions and rarefactions. Compressions and rarefactions. But in the case of transverse wave, you are going to have crest, trough, crest, trough, crest, trough, right? So now we are going to calculate how do we find the speed of transverse wave or velocity of transverse wave. See, if you want to know example of transverse wave, there are many examples are there. One example can be water waves. Drop a stone in the water, you will see some ripples coming out, outward direction. Are you seeing some ripples forming? That ripples are what? Transverse waves only, because transverse wave travel on the surface of a medium. Always remember that. I told you, if you have bomb blast inside the water, then it will be producing a longitudinal wave. But the wave, when it is reaching the surface of water, it becomes transverse, because you get waves on the surface of the water. If there is a blast in the water, or earthquake comes inside the water, don't you think that on the surface you start seeing up and down? That up and down waves are called as transverse wave. Now transverse waves being always produced on the surface of a medium, imagine that you have a rope, okay, and you want to produce some tension, like how I have in this diagram they are telling, this kind of things you want to produce on the rope. If I give you a rope, listen to my question very carefully, I am going to ask anybody. I am giving you a rope and I am saying produce this kind of waves on the rope. Can you produce? How? Stretching it and then giving somewhere you will fix one point, both will be stretched, and then what you will do? Anywhere you just pluck one thing, you will feel some kind of vibration coming out, right? All of you are getting this? What Shweta told us, tie the both side, or tie one side you tie and one side you hold tightly, and then just do a plucking in the string, there will be some kind of waves produced. I hope all of you are understanding it. True. If I say you, Shweta, don't give any tension, don't pull it, can you produce the waves then? No way, right? If I give you a rope, I say you don't fix it anywhere, don't stretch it, and then produce the waves on it? Impossible. So, for producing this wave on this string, what is must? Stretching is must. Are you getting my point? Some kind of tension is involved in this wave. Understanding that? So, that is called as the inertial factor. Now, how we derive the equation of velocity of transverse wave is with the help of dimensions. I hope you studied dimensions in the first chapter. We studied dimensions, where by using dimensional formula also we can derive the equation of anything. So, we know velocity is Lt power minus 1. Am I right? What is velocity? Velocity is Lt power minus 1. So, if I get a quantity who is having or which is having a dimension of Lt power minus 1, that would certainly be some kind of velocity only. Everybody agrees to me? Now imagine, like how I asked the question to you now, if you want to have a tension, that is a wave on a string, what you do? You can do something like this. You check, Shweta, best way. I mean, if you have all the technology, if you have all the setup in your home, keep a mass, fix it, or you are going to try it somewhere, and then you are going to pluck here, you will be able to see some kind of wave coming on the string, right? Am I right? So, here, don't you think this M is producing some kind of tension in the string? We studied this in laws of motion mechanics. This will be mg, this will be tension, isn't it? This tension, what is the dimension of tension? It is a force. Force is how much? Dimension m l t power minus 2. Thank you, you remember. Yes. Tension is a force whose dimension is m l t power minus 2. I want to get L t power minus 1. Okay. If I divide by mass per unit length, imagine, what you are going to get, you check. Gets cancelled, it will go above, you are going to get L square t power minus 2. If I would have had a root of this thing, what I am going to get? Root of this will give you L t power minus 1. Got it? That only gave us an idea that velocity of the transverse wave should be some kind of tension divided by mass per unit length. Mu is called as mass per unit length. Now, obviously, tension is going to give you mlt power minus 2. Mass per unit length is going to give you ml power minus 1. Put root over, you will get something which is kind of velocity only. This is the equation of velocity of transverse wave, which says V is equal to root over T by mu, where mu is mass per unit length. Don't forget that. Don't start using refractive index or mobility or something else. Mu is mass per unit length. And what is T? T is the tension in the string. Sometimes tension will not be given directly to you, mass will be given, mg will give you tension. I will give a question to you to make it more clear. But remember that velocity of the wave is given by velocity of a transverse wave, not longitudinal. Transverse wave velocity is given by what? Root over tension by mu, where mu is mass per unit length. Clear? Notes will be there inside, what I am writing just to explain you. If you see here, it will be there. Yes, so dimension of wave speed is Lt power minus 1, linear density is ml power minus 1, dimension of tension is mlt power minus 2, and then if you do some juggling as I told here, then you get the same thing that I told you, which is V is equal to root over T by mu. Please copy it fast. This is the equation of velocity of transverse wave. Copy it, then I will give a question to you to make it more clear. Able to see the board? Let me know if you are done writing fast. Done, guys? Karthik, Pratap, Vidyut went to offline mode. I hope you have copied. Copied?
Sir.
Everybody, shall I go to the next slide?
No, sir. Writing, sir.
Right, fast, Sanjeet. Fast. Need not write all these things, Sanjeet. Little juggling of various combinations. These things are just I have written. You need not to write. Just write this and write directly this thing. In exam, if you write all these things, they'll cut marks for that.
Sir, do put a message to my mom.
Finished, sir.
Finished? Sanjeet? Thank you, man. I hope all of you have finished. Sanjeet has finished, means all of you have done only. Okay, next. Question, come fast. Everybody, 2 minutes of time, fast. Don't take much time. 2 minutes starts. Make it fast. Mass is given, mass density also is given. Let me check. You also got same thing, Karthik?
Yes, sir. Yes, sir. Sir, even I got 0.05 seconds.
Abhinand, did by yourself or just copied from somewhere?
Sir, why are you not believing me, sir?
Okay, man. Yeah, please, Pratap, tell me.
Sir, 0.09.
Now you are not copied, I'm very sure. Yes, let us check. Fine. So here they have given the value of mu in gram per centimeter. I hope you have converted into kg per meter for SI units, because otherwise you should convert g into centimeter per second square anyhow. So mu tension is mg, and you get the value of tension as 10 Newton. When you put in the equation of velocity root t by mu, you will be getting 10 by 0.1, which is going to give you 10 meter per second. Velocity we got. Velocity is known, distance is known. Distance is how much? 50 centimeter, 0.5. 0.5 by 10 is going to give you 0.05 seconds. Simple question, isn't it? Velocity you can find by the concept that I have taught you now, and velocity is known. Distance and speed, if it is known, you cannot find time. Over. I hope you have understood now. Anybody has doubt in this question? We have found the value of velocity with the help of tension and mass per unit length, and then velocity is equal to distance, speed is equal to distance by time. From there, time is equal to distance by speed. Put in the equation, get the answer. I hope all of you are clear in this. Any doubt? I hope no.
Sir,
Yeah, please tell me.
Sir, one doubt, sir.
Please.
In mu, you are taking mass by units, sir.
Yes. mu is given as 1 gram per centimeter, right? This is mass by length only, no, it is.
Yes, sir.
So it is already given to me as 1 gram per centimeter. It means it will become equal to, I am converting into kg per meter, SI units.
Oh, okay.
So
okay.
1 gram will become 10 to the power minus 3 kg, centimeter will become 10 to the power minus 2 meter. Put and get the
Minus
value,
2.
I have got 0.1. Right, Sanjeet?
Okay. Okay, sir.
Any doubt anybody else is having? Shivaranjani, understanding what is happening?
Yes, sir. I can understand this topic, sir, but the previous topic I have not taken.
Previous no topic was there, yeah. Previously I was just revising whatever I have taught in the previous classes.
That's one I didn't take, sir. I read home today, so
Fine, fine. Anyhow, you please go through all the videos and come to me. I told you already. For all the doubts, you can come and we can have a separate class. Okay? Okay. So next is now we're going to talk about sound wave. What is sound wave? Longitudinal wave. Sound is what here? Which wave? Longitudinal. I am speaking to you with the help of what waves? Longitudinal waves. The air between you and me is getting compressed and rarefacted. So now let us talk about. This is actually little complex, and definitely you cannot understand this today. Reason is the real understanding of the velocity of longitudinal wave comes from adiabatic and aerosolum expansion, which is going to be taught to you only in thermodynamics. Since I have not taught thermodynamics and I have come to waves directly, you will have a problem in understanding this concept. I am telling now itself to you. So no issues. Now I will tell you, anyhow when I am going to teach thermodynamics, I will explain this to you in detail. Okay, coming back. So we know very well for finding the speed we are using dimensions. Here also we use dimension. So we want to get something in terms of L_t power minus 1. In the case of sound wave, there is nothing called as tension, because sound is travelling in the air or in the medium. Where is the question of tension? We don't have to use tension here. But some other dimensions, let us check, which can help me in getting this thing. So we found that modulus. Now we have three modulus, right? Young's modulus, bulk modulus, and shear modulus. Modulus is having always same unit. Modulus is what? Having the unit same as which? Stress, right? Stress is force by area. So if you see the unit of any, here they have given bulk modulus, but any modulus if you take, it will be ml minus 1 t power minus 2. And density, mass by volume, is ml power minus 3. If you solve this, what are you going to get? L2 t power minus 2. Once again, if you put root over of this, what you will get? Velocity you will get, isn't it? So I can say that with the help of dimensional analysis, velocity of longitudinal wave is given by root over, I should not write b actually, more general expression can be v is equal to root over, I should say elastic coefficient divided by density, because in the case of solids we are also using Young's modulus. Some place we were using v is equal to root of bulk modulus by rho. If you remember bulk modulus as k, you can write k also. In solids we also write velocity at root of Young's modulus by rho. This also some books will write. Both are correct. This will be in the case of air or gaseous state, and this will be in the case of solids or liquids. Or liquids will have bulk modulus, sorry, gas, or I should write fluids. Gas and liquids will be coming under the category of fluids. So for fluids, the velocity of the longitudinal wave will be given by root over bulk modulus by density, but for solids, velocity of longitudinal wave is given by root of Young's modulus by density. First you copy this. The heading is what, Abhinand?
For bulk, use of bulk modulus for fluids, right?
Yes.
No.
Air is also a fluid only, no?
Yes, sir, both are liquid.
Yes, that is gas and liquid.
Yes, sir.
Yes. So velocity of longitudinal wave is given by root over elastic, that's why I wrote elastic coefficient, because in the fluids case it is root of bulk modulus by density. I hope you remember what is bulk modulus, by the way. Bulk modulus K or B is equal to pressure divided by delta V by V, volumetric strain. You remember this? Sometimes they will use negative sign also. Negative sign indicate that volume is decreasing. Do you remember this or you forgot? I hope something you remember from mechanical properties of solids chapter, isn't it? Bulk modulus is pressure by change in volume by original volume, called as volumetric strain. Negative sign indicates that volume is reducing. Everybody is clear in this? Any problem? We have just taken the help of dimensions, nothing much. The problematic part is going to come after this only. Can I proceed? Online people? Karthik, without video, can I proceed?
Yes, sir. Yes, sir. Yeah, fine, sir. Fine, sir.
Pavitra, Kirti, understanding what is happening?
Yes, sir.
Vacation started? Enjoy. Okay. So, same thing what I wrote in the previous page. For linear, that is for solid bar or something solids, we are using velocity is equal to root over Young's modulus by density. Okay. Now comes the main part. So, we want to find what is the velocity of longitudinal wave. There are two ways. General formula is modulus by density. Don't forget this, root over any modulus, not shear, either bulk or Young, divided by density of material is going to give me velocity of longitudinal wave. That is the general mother formula we say. Now, from that general formula, Newton derived the velocity of longitudinal wave formula in terms of pressure. So, what he told, see, Newton's formula, what he told, now again the word isothermal process, it may be little difficult for you because you have not studied this. Adiabatic process, isothermal process, these are not known to you much because it comes under the topic of thermodynamics. We will learn it in the upcoming class.
Chemistry, sir.
It may be there, but I don't trust how much you know. Anyhow, so I'll proceed here. So you know that PV is equal to constant, right? That you know from very basic. PV is equal to nRT or PV is equal to constant. Okay. So if PV is equal to constant, see this step again. If you understand differentiation, you can understand this. We differentiate the function, right? P, V both are variable. So I am writing P into delta V plus V into delta P. UV rule. U into V rule. I hope you know the basic differentiation. You know this? You know what I have done here? PV is constant, differentiation of constant is 0. So P del V plus V del P is equal to 0. From here, if I further solve, I will get P is equal to change in pressure by volumetric strain. Don't you think it became something like a bulk modulus? Can you feel that? If it becomes something like a bulk modulus, what Newton did, he replaced the bulk modulus with pressure and he wrote velocity of longitudinal wave is root over pressure by density. Mother formula is velocity of longitudinal wave is root over bulk modulus by density or Young's modulus by density. Newton told velocity of longitudinal wave is root over pressure by density. How he replaced pressure B with P? By this equation only. So again, I hope you are understanding whatever we are talking is valid for fluids because he not replaced Young's modulus, he is replacing bulk modulus. It means whatever I am talking now, it is for which medium? Gaseous medium or liquid medium. Okay. Now, if I put the atmospheric pressure here and if I put the value of density of air, then what I should get? I should get the velocity of the sound in air. Get my point? Because normal conditions, what is the atmospheric pressure we have? And what is the density of medium, that is density of air? If I put these two values, I should be getting velocity of sound in air. We already know velocity of sound in air is approximately 330-340 meter per second. But when we put in this formula and find the value of velocity, then we will not be getting 330 meter per second. We will be getting 280-270 meter per second only. That is where Newton's formula failed for this longitudinal wave. And then we have something called as Laplace correction. I will talk about that. First you copy it. Have you copied it? Check if you have copied it, make it fast if you are
No,
not
sir.
copied.
No, sir.
Make it fast, copy it fast. Then I will talk about Laplace correction. First you copy it. Let me know if you are done. Let me
Done, sir.
done.
Finish.
Okay. Shall I proceed? Thank you. Now take this question. A very basic question, which I just now told to you. Those who don't know about the basic values of this thing, then you know what is atmospheric pressure, right? 1.015 10 power 5 Pascal. 1.015 10 power 5 Pascal, isn't it? So use the value of atmospheric pressure, and you know you want density also, right? P by rho. Density is equal to mass by volume, isn't it? They have given the value of mass to you, and what is the volume you are going to take? This is what you should take if you don't know. That 1 mole of any gas occupies 22.4 liters of STP at STP. So volume also I gave to you. Volume is 22.4 liters, mass is 29 × 10⁻³ kg, and atmospheric pressure is 1.015 into 10 to the power 5 Pascal. Everything I told you now. Solve and get the answer. Remember, the volume is given in liters. How to convert liters into meter cube? 1 meter cube is 1000 liter. Remember this. 1 meter cube is equal to 10 to the power 3 liters. So convert if you want to convert accordingly. If you don't know, please remember this. 1 liter is 10 to the power minus 3 meter cube. So 22.4 into 10 to the power minus 3, they will get cancelled. 29 by 22.4 will give you the value of density, and then atmospheric pressure also you know. Put and get the answer. Just basic solving, some no hi-fi things in this. If you understand that velocity is equal to root over pressure by density, pressure value is atmospheric pressure, density is mass by volume, mass is given to you, volume I told you now, and remember this forever, at least till you are in school life, that 1 mole of any gas occupies 22.4 liter at standard temperature and pressure, STP, if you don't know this. So when you solve this, density you will get as 1.29, and then when you use Newton's formula, you will get atmospheric pressure divided by 1.29. When you solve, it will approximately come as around 280 meter per second. I have told the answer itself, you can solve later, I don't want to spend more time on this. So if it is 280 meter per second, definitely it is not the real value of sound's velocity in air. It means there is some issue with Newton's formula. Newton has told the formula of velocity as root over pressure by density, which is not true. How we came to know? By this only we came to know. When we found the velocity of sound in air, we identified that it is not coming around 330 meter per second, and we concluded there is some issue. What we did after that? After that, we applied a correction called as Laplace correction. Laplace is another person, another physicist. Actually, he is having he is in mathematics also. That guy, he gave a correction over the Newton's formula. And what he told you know? He told that the assumption made by Newton that the process is isothermal is actually wrong. Now, if you don't know what is the meaning of thermal, isothermal means temperature remains constant. As the name says, isothermal. There is something called as adiabatic process. You know about that? What is the meaning of adiabatic process? No exchange of heat between
Heat.
system and surrounding, but all the parameters will change, isn't it? Pressure, volume, time, everything will, not time, temperature, everything will change. P, V, T both will change. If you have isothermal process, temperature is constant. Isobaric process, pressure is constant. Isochoric process, volume is constant. But adiabatic process, nothing is constant. P, V, T, everything is variable. So what Laplace told? Laplace told that the variation, see what is mentioned here. The pressure variations in propagation of sound waves are so fast that there is little time for the heat flow to maintain constant temperature. Therefore, the process is adiabatic and not isothermal. Very important statement. This is what made Newton's formula to have error in the calculation of velocity of sound wave. Are you getting my point? He took the process to be what process? Isothermal. He took isothermal. Who? Newton. But what is the process really? Adiabatic process. So what Laplace did? He assumed, there we took PV is equal to constant, right? Those who have studied thermodynamics, they may know that as per the adiabatic change, PV power gamma is constant. Kirti, are you aware about this? No, you studied thermodynamics, right? Hey, you wrote exam recently on thermodynamics and physics in school. So forgot that. Pavitra, have you heard about this PV power gamma is constant? Anywhere you heard this?
Yes, sir, we have written exam.
Exam you read, I am not asking that now. I am asking, do you remember that adiabatic relation between pressure and volume is PV power gamma is a constant? Unmute yourself.
Yes, sir.
Okay. I will ask you what is gamma now. Tell me what is gamma. Don't know, don't say. Yeah. Thermodynamics you studied, that's why I am asking you. Unmute yourself.
I just marked up for exam, sir, that's all.
Gamma is equal to Cp by Cv. Anything you are remembering now? Gamma is ratio of Cp by Cv.
Pressure.
Others, I mean, Kirti, anything came to your mind when I said Cp by Cv? Nothing came? Say nothing came. No, don't remember this gamma is equal to Cp by Cv? No, okay, no issues. Anybody, like Pratap told yes, sir. Anybody else who remembers this? Who knows this? We will learn all these things in thermodynamics. But those who have learned, you have also learned thermodynamics in school, right? Shweta Shinde, have you heard this? Cp by Cv, gamma? Heard somewhere? Okay, thank you. So gamma is Cp by ratio of, now what is Cp, what is Cv?
Constant and constant.
Oh, ho, ho. Huh? Heat capacity at? Specific heat capacity at constant pressure is called as Cp. Specific heat capacity at constant volume is called as Cv. Now, Varshika, in Cp and Cv, what is the meaning of Cp and Cv? Which is bigger? Cp is bigger or Cv is bigger? Because Cp minus Cv is equal to R. Why Cp is bigger? Why not Cv? Knowing all these things? Not knowing itself. Very good.
Pressure will be exerted more than the volume to remain that volume constant in that distance from the.
Okay, something you told, Shivarajani, thank you for saying something. I am happy. But the thing is, Cp and Cv, Cp is more than Cv, it is true. Reason for that is purely based upon first law of thermodynamics. Delta U plus P delta V. If volume becomes constant, del V becomes 0. If del B becomes 0, del Q becomes del U. Whatever heat you supply, it is used only for change in internal energy, right? So with less heat itself, you will have the temperature change. Okay, first you should understand what is the meaning of specific heat itself. What is specific heat? Specific heat is the amount of heat energy required to increase the temperature of unit mass of substance by unit degree Celsius. Are you aware about this? Have you heard it somewhere? Specific heat means how much, suppose you have 1 kg of something, anything, 1 kg of brick. It is at temperature of 24 degrees Celsius. If you heat it, it will become 25. How much heat energy is required for 1 kg of brick to become 24 to 25? That heat energy is called as specific heat capacity. Are you getting my point? Specific heat means amount of heat energy required. Not required now, but I am telling you because I am going to suddenly use the word gamma in this derivation. You should know some basics. You should not scold me, that is why I am telling you. So specific heat means amount of heat energy required to change the temperature of unit mass of substance by unit degree Celsius. Now, if you compare Cp and Cv, first of all, Cp and Cv are there only in fluids, only in gases. It is not there in solids. I don't know how many of you are understanding this. So, Cp means specific heat capacity at constant pressure, Cv means specific heat capacity at constant volume. If I maintain constant volume and I do not allow the volume to change, whatever heat I supply will be used only for one thing, that is changing the internal energy. So, with less heat itself, my temperature will increase by 1 degree. But in the case of Cp, where the pressure is constant, if I supply the heat, it will be used for two things, del U and P del V or delta W. It means whatever heat you are supplying is used for two things. One is for increasing the internal energy, second is work done by system on surrounding. So, more heat is required to increase the temperature by 1 degree Celsius. That is why Cp is more than Cv. Out of all of you sitting there, if one understood, I am successful, because many of you are not knowing about thermodynamics. But that is the reason why Cp is more than Cv. I will teach once again when I teach thermodynamics. So, Cp by Cv ratio is called as gamma, and as per adiabatic change, Pv is not constant, Pv power gamma is constant. Okay. Now, what we will do, we will differentiate this. Previously it was easy, we wrote P del V plus V del P is equal to 0. Now, we cannot write that because it is Pv power gamma is constant. When we differentiate, you will get P into gamma into V power gamma minus 1 into del V. Actually we took this as constant and then we differentiated a second function, and then V power gamma into del P is equal to 0. Are you getting what I have done? UV method.
Yes, sir.
UV method means first I have taken P as constant. What is differentiation of V power gamma? It will become V power gamma minus 1 and multiplied by gamma, isn't it? Into dV. And then if you differentiate, if you take V power gamma as constant, differentiation of P will become del P is equal to 0. Further, if I solve, I am going to get gamma into P as this value. Further, if I solve, I am going to get gamma into P as same what I got in the previous scenario. And now you can see P will be gamma into P will become equal to this B, bulk modulus. It means I should not replace B with P, I should replace B with gamma into P. Now the new formula will become velocity of longitudinal wave with Laplace correction will become equal to root of gamma P by rho, where gamma is what? Ratio of Cp by Cv. And gamma values for different gases are different, diatomic gas, triatomic gas, monatomic gas, diatomic, linear, triatomic, nonlinear. I will teach all these things in kinetic theory of gases. Bad thing what we have done is we have skipped 2 chapters in between because of your demand, and I came to this chapter. Not your demand, many are demanding. You don't know why when I demanded. Some children are there who are asking this. So, after if you would have come in the order, definitely you should have understood what is the meaning of this gamma, how it came. But now I am trying to make you understand how much, what I can do maximum. So, remember that gamma into P by rho is going to give you velocity. So, what is the general formula of velocity of sound wave? Root of elastic coefficient by density. What is Newton's formula for velocity of longitudinal wave? V is equal to root of P by density. What is the Laplace correction formula of velocity of longitudinal wave? Root of gamma into P by density, where gamma is the ratio of Cp by Cv. As of now, gamma will be given to you, and if you put the gamma values, you will be getting. So, for air, that is for air, gamma is 7 by 5, and gamma is 7 by 5, put 7 by 5 and solve, you will get exactly 331 meter per second. It means this formula of velocity of longitudinal wave is correct, because by using Newton's formula, I was getting velocity as only 280 meter per second, but when I am using Laplace correction, I am getting velocity of sound wave as the real value, experimental value, that is 331 meter per second. So, that is the correct value of velocity of longitudinal wave. Clear? Is it clear? Very simple thing actually, very simple thing. Please copy it fast. Make it fast, please. Done? Thank you. So, we have got the value of velocity of transverse wave as root over T by mu, where T is the tension, mu is mass per unit length. Velocity of longitudinal wave, general formula is root over modulus by density. Newton's formula is root of pressure by density. Laplace correction is root of gamma into pressure by density. If all these things are clear to you, then I can go to the next page. Shall I go to the next slide with your permission? Make it fast, please. Make it fast. Those who are writing here, make it fast, please. Sugendran Dambi,
Excuse me, sir.
where are you, man? I'm not able to. I saw you. How are you, man? Exam over?
Yes, sir.
Now, vacation.
No, sir.
Why, man? School is still there.
Yes, sir. Today I have went and come, sir.
Because many state board schools have given leave now for 10 days.
No, sir. They are not yet completed the portion, sir. So slot, sir.
Okay. Bad luck for you. Did you see all the last videos? No, right?
No, sir. Tomorrow I will go to sir.
Tomorrow is leave or tomorrow is working for you?
Tomorrow leave, sir.
Shivaranjani, can you just explain what? Can you just explain the derivation of time? Shivaranjani, see my mouth what you're saying. Derivation slash time you wrote. What you're asking?
Sir, one time.
Oh, one time you're saying. I derivation means which derivation? This derivation you're saying.
Yes, sir.
See here, PV power gamma is constant. That you should understand in thermodynamics. It is there. Now, if you differentiate this function, if I differentiate and show you, let me open my, yes. So, I differentiate this function, UV method. You know UV, Shivaranjani?
Yes, sir.
Oh.
Nothing, sir. One problem.
I am not asking who taught you. I am asking do you know or not? Yes or no, you should say.
No, sir.
Very good. Thank you. So, if you take P constant, you have to differentiate V gamma. So, when you differentiate d by dx of x power n, Shivaranjani, how much? Unmute for 2 minutes, please, Shivaranjani.
Yes, sir.
D by dx of x power n. You remember the formula? Say no if you don't know.
Yes, sir. X power n minus 1.
X power n minus 1 by 1. Hey, you mixed it. Integration and differentiation mixed both. N minus 1 she told, but she told x power n minus 1 by n. Tell me again, Shivaranjani, please.
X power n minus 1 by n minus.
She mixed both, no? X power n plus 1 by n plus 1 also it is the integration. Differentiation will become n times of x power n minus 1. Okay, Shivaranjani? Jokes apart. Is it clear? You remember now a little bit?
Yes, sir.
Yes. So, same thing we have done here. So, gamma, you will take it down. That's why I written gamma into V power gamma minus 1. Understood? Next what I did, I took V power gamma as constant and differentiated P. That's why I wrote del P. Del P means D of P. Understand that. Del P here it is there, del P. If you are getting confused by this del thing, you change to dP, no problem in that. Are you getting, Shivaranjani, what I have done? If you are confusing with del word, you can write like this, P gamma V power gamma minus 1 into del V plus V power gamma into dP is equal to 0. Are you comfortable in this? How it came your understanding now? Huh? Abhinand?
I still don't get it, sir.
You
Every step I don't get it,
you
sir.
cannot get it, man, because you are a pure science student. You know this thing at least.
Yeah.
This thing you know at least.
And that I know the simple differentiation, sir.
After that, what is there? You know UV rule.
That I'm, not sure with that much, yeah.
Oh, okay. So UV rule says U into V dash plus V into U dash. Dash
Okay.
means differentiation, Mr. Abhinand.
Thank you, sir. I
Okay, you
understood.
Understood, Shivaranjani? You are teasing me or really you understood?
Easy part, sir. That.
Now you understood, no?
Yes, sir.
Thank you. Abhinand.
So when you differentiate V to the power gamma, it becomes gamma into that thing, sir.
Yes,
That
exactly,
expression.
exactly.
Okay, fine. Got
And
it, sir.
same way when we took V power gamma constant, then differentiation
That's
of P
dP,
is
delta
dP.
P.
Yes. Understood now?
Fine. Yeah, sir, got it.
Thank you, man. Everybody else is
I
clear?
just don't get it. I don't get that small expression that you made for differentiating V to the power gamma.
Where, man? This del.
Sir, the second step, sir, P into gamma into V to the power gamma
Yes.
minus 1. That
Now,
one.
now you understood.
I understood why it is there, sir. I don't know how it came, sir.
At least now you understood how it came.
Sir, I know it came. I don't know how you got that expression, that's all.
Which expression you are saying?
I get
P.
the idea of it, sir. UV method is U into V dash plus V into U dash, sir.
Very good. Yeah.
That so when you differentiate V to the power gamma, you get that expression. That is gamma into
Yes, yes, yes.
second step.
Yes.
That one. I don't know how you're getting that. Yes.
Hey, man, we are getting by this formula, Thambi. D by,
That's all.
if I ask you, Abhinand, D by dx of x power 6, what will be your answer?
So 6x, 5, 6x to the power 5.
Yes, how it came? You wrote this in the coefficient, x and 6 minus 1 you did, no?
Yeah.
Here we have v power gamma, right?
And why is there del V, sir?
Hey, that is differential. It's actually called as, what do you say, both are variables. So we are writing differential of del v and differential of p. It is not constant, so for taking it to be outside.
Okay, sir.
That if you want, sir, come sit with me Monday, I will teach you. But you understood how this gamma into v power gamma minus 1 came?
Yeah, that I get it now, sir. Yeah, sir, got it, sir.
Understood?
Yeah, sir.
Okay. No more questions taken after this. I'll move next page. Shall I go? Shall I?
Yes, sir, you can.
Thank you, man. So now this question comes in the school exam sometimes. What are the factors that affect the speed of sound? Anybody knows? Speed of sound?
So density of air, sir.
Density of air. Very good then. Density of air, how it can change, Mr. Abhinand?
So when you go more higher in the, when you go more higher, sir, density of air might change because.
Might don't say,
I don't
man.
know, sir.
Inversely proportional.
Okay. We'll go one by one. Let us not jump. But some good density is definitely going to affect because of humidity. Water may get some moisture, it will change its density, isn't it? Density means mass per unit volume. If you get moisture in the air, it will have more water particles. Its density will also change. Okay, anyhow, we'll go one by one. So first thing is medium, as Mr. Advait told in the class, medium. Yes, first is the medium. You know that velocity of sound in solid is maximum. I hope you know this. 330 meters per second is the lowest speed of sound in air. If you go to liquid, it is more than that. If you go to solid, it is much more than that. So why it is like that? Because of the lattice structure. In solids, you have more particles nearby. When wave travels, it hits very fastly. Liquid, you have particles separated more far away. In solid, in gas, you have much more far away. So obviously, velocity of sound in liquids will be, and solids will be maximum, and gas will be minimum. Am I right? So that's the reason for having different velocities of sound in different medium. So the first factor that affects the speed of sound is the medium. If the medium is solid, it will have the maximum velocity. Medium is gas, it will have the minimum velocity. I hope you are clear in this, right? Next, second property or second factor. Second factor is effect of temperature. Do you know that if it is a hot day or if it is a cold day, it also governs what is speed of sound? It also governs. Why? Let us see why.
Yeah.
I'll tell you why. Velocity formula we know now. Velocity of longitudinal wave is what? Gamma into p by rho, isn't it? This formula is known to you. What is rho? Mass by volume. And what is p into v? nRT. For 1 mole of gas, RT. So I am writing gamma into p by rho as gamma into RT by m. Understood how RT by m came? Rho I am writing as mass by volume. And p into v I am writing as RT. I am taking n as 1 mole of gas. So velocity becomes equal to gamma root of gamma r t by m. You can see very clearly velocity is proportional to root of t. If temperature will increase, velocity will increase. On a hotter day, your velocity of sound is more compared to a colder day. So, you know one thing, in cold regions, when you call somebody who is very far, he may not be able to hear. But in the same intensity of sound, if you are calling somebody on a hot day, he can easily hear you. Because on a hot day, velocity of speed, that is speed of light, will be more compared to a cold day. Are you understanding this? This kind of questions can come theoretically. If temperature is increasing, speed of sound also increases. What is the ideal gas equation, Advait? PV is equal to, know this? So, if you take n value as 1 for 1 mole of gas, what will be PV? RT. That is what happened here. So, density became, I am writing one step for you, gamma into density became mass by volume, already P is there, and PV became equal to RT. That is why this equation came. Understood, Advait? Sure? Okay. I hope it is clear. Can I proceed further? Third factor? Third factor that affects the velocity of sound is the humidity. I told you, effect of humidity. If humidity is increasing, density of air is actually decreasing. Humidity of the air is increasing, density of the air is decreasing. So, the velocity of the sound in humid air is more than velocity of the sound in dry air, because density and velocity are inversely proportional. V is equal to root over anything by density. If density is going to increase, velocity is going to decrease, and if density is going to decrease, velocity is going to increase. So, if I ask you dry air and humid air, in humid air we have a greater velocity, in dry air we have a lesser velocity. Don't.
Can we also look at travels in liquids?
Exactly, faster it travels in liquid. That way also you can think. Yes, that way also you can think. You are thinking in the terms of medium itself is changing. Yeah, you can think.
Sure.
Yeah, you can think in that way. Humidity is adding some liquid content to the air, isn't it?
Yes, sir.
I hope it is clear to everybody. Effect of temperature, effect of humidity, and effect of medium, right? Factors on which what depends? Speed of sound depends. If it is clear, shall I proceed further? Shall I proceed further? Okay. Now let us talk about the last topic of this chapter, beats. What is a beat? Music. What, man? What is beat? Drum.
They got in school, sir.
Tell me.
So, two wavelengths, sir.
Two wavelengths.
And the difference between them are two different wavelengths. No, two different frequencies, sir. When they have some difference, the number of, that's the number of beats, sir. Let's say one is 456, other is 454, sir. There will be two beats between them.
Something, you know, I appreciate that, but I'm not asking that to you. I'm asking what is a beat?
Sound, sir, like a beat.
How it is different from normal sound?
Normal, sir.
Okay, something, you know, I'm appreciating that. Good. Let me tell you.
The low frequency sound, sir.
Low frequency sound? No. Okay. I'll tell you. See, when two sound waves, listen to me very carefully. You know very well, if two waves, what happens if they are moving in same direction? What happens when they are moving in opposite direction? Everything you learnt now. You learned that if two waves are moving in same direction, based upon if they are having crest together, it will become double crest, trough together, double trough, crest together, zero. If they are coming in opposite direction, they will form a standing wave. You know all these things now. If you have two waves, please imagine here, there are two waves. One wave is moving like this, okay. There is another wave which is moving with a slightly different frequency. It may have a frequency of 100, another may have a frequency of 105 or 106, little different frequency. See what will happen. Frequency means what? Number of oscillations per unit time. So, it will go like this, and first it will be very near, then it will have little more, then it will have little more, and then it will goes. It will become like that because it has slightly different frequency, but when you go in the longer run, it will keep on changing. So, you see, initially the waves were almost having crest and crest together, then they got some separation. After some time, I am even getting a crest and trough together, and once again it will have the same thing. What I am trying to tell you, the combination of these two waves is going to result in something like this. Are you feeling it? When they superimpose, initially more amplitude, then reduce, becomes almost 0. Once again increase. Once again reduce. Once again increase. This is known as beat. Beat is superimposition of two waves which are moving in same direction but having slightly different frequency. Slightly different is very important, not much different. Because what I want, have you seen some music beats also? It will be like this only, no? Have you seen music beats will be like this only? In some instrument it comes, you can see that.
Yes, sir.
So heartbeats.
Heartbeat also, very good. It will also be like going more, becoming less, once again becoming more. It is not crest and trough. It is like this, where two waves have superimposed, and when they superimposed, that time we got this kind of pattern. You know how beat sounds like? Have you heard beats? Don't say I have heard heartbeat. I am talking about sound beats now, apart from heartbeat. See how it sounds. I don't know if it will play or not, let me check. You are able to hear that side?
No, sir, I can't, sir.
No, sir.
Here also you are not able to hear, man. Don't think we are hearing.
Just do the sound, sir.
Do it from our mouth, you are saying.
Yeah.
Mouth, how I can do, man? Huh? Beatboxing. Hey, come and do, man. Why it is not playing? Wait. Something let me do.
You can go on YouTube, no, sir.
Thank you, man, for suggestion. I think I have to increase sound here. Ipo varum. You are hearing? One second, I'll pause it. See.
Sir, it's like a whistling sound, sir.
I'll tell you. Initially, what I have done, no, two waves are passing. Both waves are having almost same frequency, slightly different frequency. But when they superimposed, you see how it will come. It will be having more frequency in less time. You see that. Now only two waves are there, not superimposed till now. They are going to superimpose now. Yeah, superimpose. See now how it is vibrating. Not hearing anything?
So we can't differentiate the sounds, sir. Like it's same, like
For here, you are able to differentiate? Wait, here. I will try to increase the maximum sound possible is only. Where is the sound is coming? I will put my this thing there. Where is the speaker of this TV? Hearing something? Hearing now?
Yes, sir.
I think you have to increase your volume from your side or put headphone, then only you can hear clearly.
yeah, sir, okay, I can hear it, sir.
Hear it, no? Initially you would have heard like slowly going. When they superimpose, it became like a. Did you feel that? Not felt, I'll share the audio clip with you. Go and browse in YouTube like how Sugindran Thambi told. You can see in the YouTube also. What, Mr. Sugindran? Isn't it? So, whatever, man, write the definition of beat first. Leave with the audibility of beat. What are beat? Beats are periodic and repeating fluctuations heard in the intensity of a sound when two sound waves of very similar frequency interfere with one another. Copy it fast without wasting time. Copy it fast. The definition of beats is on your screen. How is a beat defined as? Have you copied? Not required. Copied?
Yes, sir. Just a second, sir. Just a second. Yes, done, sir.
Yeah, okay. Beauty of online classes, 8:30 happens, drop, go, eat, sleep. Nobody is going to ask anything. Here you cannot go until I leave you. See, online people, I'm seeing every day this thing. 8:30, 8:40 happens. Slowly, 25 will become 24, will become 23. Will not hear also. People were there. Suddenly they disappeared. They would have slept also now by now. Okay, coming back. So shall I proceed further? Yeah.
Yes, sir.
Sugindran there? He is there. He is there. So let me take two waves. See, again, you may have confusion now. Why he is taking suddenly a cos kx minus omega t? Why can't he take sine? See, NCRT book has taken cos. That's why I have taken cos. Nothing else. Remember, any simple harmonic motion can be y is equal to a sine omega t also, or x is equal to a cos omega t also. Both are harmonic functions only. Since NCRT uses cos, I am using cos now. No other reason. You can use sine also if you want to use. Again, I am repeating. No problem in that. It is going to give you a harmonic function only. So if I am taking y1 as a cos kx minus omega 1t and y2 as a cos kx minus omega 2t. Please pay attention here. I have taken omega 1 and omega 2. Why? Because they have slightly different frequencies. So when they have slightly different frequencies, now when I superimpose them, first I have taken x is equal to 0. If x is equal to 0, a cos omega 1t and y2 is equal to a cos omega 2t. When you put it by the principle of superposition, y will become equal to a cos omega 1t plus a cos omega 2t. It is just a common out, cos a plus cos b. Cos a plus cos b, as trigonometry says, 2 cos a minus b by 2 or a plus b by 2, isn't it? So when you solve, you will get 2a cos omega 1 minus omega 2 by t into cos omega 1 plus omega 2 by 2 into t. Now please, here one thing you should understand. I can take this omega 1 minus omega 2 by 2 as omega b and omega 1 plus omega 2 by 2 as omega a. Now please, something important I am going to tell you, please pay attention. So now I got the equation of wave as 2a cos omega bt into cos omega at, where what is omega b? Omega b is this. And what is omega a? Omega a is this, right? This is called as omega a. Here I am taking, and this I am taking as omega b. Now, have you copied this first? Tell me.
How is omega b greater than omega a, sir?
I'll talk about that. First, you copy this fast. All of you, please copy it. Copy this equation fast. You copied?
Yes, sir.
All of you have copied? Copy this also. I'll explain it to you. First you copy and finish copying. Copied? Done copying? Tell
Yes,
me
sir.
yes or no.
Yeah, sir.
Shall I?
Completed, sir.
Okay. Okay, now you see here, previous page if I go. Yes. So, this term is there, no? What? 1 second. Yes, this term. Forget about this step now. Up to here, everything is clear? This term is clear to you? How it is come is
Yes,
clear
sir.
to you?
Yes.
Now, this 2a cos omega bt is taken as capital A, and I am writing the equation of this superimposition y is equal to a cos omega a t, where what is omega a? Omega 1 plus omega 2 by 2, and what is a? What is a? A is 2a cos
Omega B.
omega bt. Am I right? Now, for some time, let us forget this omega b is much bigger than omega a. What was mentioned? Once again, we can come back. So we understood what is the value of y is equal to a cos omega t. How it came in understanding? Where a is given as 2a cos omega bt, right? I am saying for some second you just forget that this omega b is much bigger than omega a. As of now, you forget this. So if I remove that omega b is much more than omega a, everything is clear to you. Apart from that,
Yes, sir. Yes, sir.
okay. Now, let me talk about beat frequency first. So beat frequency is the difference in frequencies between the two waves. That is, first wave has some frequency, second wave has its own frequency, but it is slightly different from the first wave. Difference in the frequencies of these two waves is known as beat frequency. Are you clear in that? What is beat frequency? Beat frequency is the slight difference between what? The frequencies of both the waves, omega or minus omega. Copy it. Why I have put modulus sign, you know? Why have I put modulus sign in? Because omega 1 may be lesser than omega 2. So you should get if you get a negative value, modulus will make it positive. That's why we have taken a modulus value, of omega 1 minus omega 2. So beat frequency is the difference in the frequencies between of the two waves. Have you copied this? Okay. Now, first you answer for this question. Think and answer. Think and answer. Very simple question. Think and answer.
It could be 387 or 381, sir.
It can be 380.
1 or 387
So I guess 387.
or 381
381 or 387.
or 387. Yes.
Okay.
Either.
Okay. Correct, obviously correct. Why I am saying it is correct? Because they have given the value of one frequency as 384, that is 4k is having frequency of 384, and they are saying it is giving a beat 6 beat in 2 seconds. It means what? 6 beat in 2 seconds means it is 3 hertz. If it is 3 hertz, 6 by 2 it is 3. So either it can be 381 or it can be 387. We cannot comment it will be 381 and 387. What is that? Obviously both is possible. But now talk about this question. Now solve this question. Little different from that. Think and tell me the answer. Think and tell me the answer of this question. two sitar strings A and B playing the note ga. What is ga? Sare ga ma, that ga. Yeah.
330 hertz.
3
30 hertz.
330.
Yes.
Okay. Others, any answer? Loudly,
330 or 380.
330 or 318 you say, okay.
Can't be 318 because they reduce the tension, right?
Okay, that I am not saying the answer, I am just asking you people now, okay. So, as he is thinking, there are two possibilities. As Anbarsi has told, yes, there are two possibilities. One possibility is, yes, beat frequency is 6 hertz, so it will be 318 or 330, right? But in the previous question, I gave the answer as both the answers, right? But here, as Abhinand is very correctly telling, we cannot say both the answers as the answer. Reason is, they have very clearly mentioned that there is a slight reduction. The tension in string A is slightly reduced and the beat frequency is found to reduce to 3 hertz. So, if there is a reduction in the frequency of it, then obviously we will have the value of beat frequency as, what answer you told Mr. Abhinand? Unmute yourself.
So I said I couldn't 330, I said 330.
But what is
more? Frequency should have been more.
So, what is the answer?
330 hertz.
What you are speaking, man?
What did you ask me, sir?
I asked that, what answer you told?
I said 330 hertz.
How it can be correct?
Oh, then I'm wrong. I said 330 hertz.
Yeah, but why it is wrong your understanding? Because
Yeah,
they are very
it is.
clearly saying that frequency has to be reduced. It is found to be reduced, isn't it? If it is found to be reduced, then 324, 330 is more than that, right? And 318 is less than
Yes.
that. So obviously 318 will be the answer for this question, not 330. Understood?
Also.
Beat questions will be very simple, school level at least. One frequency will be given to you. Either they will give another frequency and ask you to find beat, simple subtract both frequencies, or they will give beat to you and ask you to find a second frequency. It can be both plus or minus. If they give this kind of case where you are very sure that it is reducing or it is increasing, then you can more easily say the answer as either 318 or 330 in this case. Are you getting my
I have
point?
a doubt, sir.
Please ask me, Abhinand.
So they decrease the tension, sir. That means the frequency is also going to decrease. It did.
Yes, obviously.
So initially it was 6 hertz. Then after they decreased it, it's going to become lesser. They said it's become 3 hertz.
Yes.
That means it can't be 380.
See, understand what I am saying.
330.
The tension in the string A is slightly reduced and the beat frequency is found to reduce to 3 hertz. If the original frequency of A is 324 hertz, what is the frequency of B? See, they are not talking about the frequency of B, they are asking, understand, the initial case they are asking.
Okay, I thought there is a tension in B, not A.
No, 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 it's about, they are talking only about A here, not B.
Okay, wrong case.
Are you getting my point? We can solve some more questions in the offline session. When we meet, I will give some worksheets to you. You can solve more questions. Kirti, Pavitra, have you got the previous worksheets of oscillations and waves?
Yes, sir.
Have you solved it? Are you solving it?
Will do, sir.
Please do, here. You are in vacation now. Don't be lethargic. Complete the worksheets. Ask doubts to me. We can arrange a separate session for doubt clearance. Okay? Okay. So, one thing before we close the session. Then what was that? That how this omega B and omega B. I'll go to that page. Yes, this point. Yes, you had doubt, no? Omega B, how they are more than omega A, right, Abhinand?
Yes, sir, I had a doubt in that. Sir.
Yes. So this doubt is very correct doubt. It is wrong. It should be omega A much bigger than omega B. Obviously, omega 1 plus omega 1, omega 2 are very slight, very near values. It will be near to 0 actually, isn't it? 400, 402. What you will get? 2 only you will get. 2 by 2 will become 1.
Is 1.
Yeah, it is going to be very big value. So here there is a mistake in writing. This will be what? Omega A is much more than omega B. Please change it wherever you wrote. Wrongly written. I verified it from the NCERT also. That's why I told you, I'll tell you at last. So here omega B is not more than omega A. It is wrongly given. It is omega A much more than omega B. Have you made the change? Right? So with this we come to an end of this chapter, and there are so many things to still do the numerical solving. But I hope if you are there in all the classes properly, it is simple chapter. Equation of progressive wave, equation of reflected wave, equation of standing wave, equation of superimposed wave, equation of this beads, everything is very similar. If you are understanding one, understanding other things also. If you still have doubt remaining, you can always meet me and ask your doubts. Next class, we will be starting talking about what? Thermodynamics. Tomorrow no class, tomorrow is church I am saying, Christmas. Christmas means holiday only. Okay Abhinand, you asked me doubt. Okay?
Yeah, sir, yeah, sir.
Okay man, enjoy your holidays. So bye bye, take care. We will meet again on next Tuesday where we will learn thermodynamics.